Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's podcast is brought to you by TRX Dinosaurs. They make innovative puppets, posable sculptures, and animatronics, mostly of dinosaurs. And you can find out more at trxdinosaurs.com. This week we have an interview with John Hutchinson, who is a professor of evolutionary biomechanics. And obviously, since he's on our show, that means that he does biomechanics of dinosaurs, which is pretty fabulous. Mm-hmm. And he's worked on some really cool projects. We also have Dinosaur of the Day, Pro Compsognathus of Jurassic Park fame, as well as a bunch of dinosaur news. But as always, we'd like to start by thanking some of our patrons who help us keep the podcast going. And this week we would like to thank Chris, Nicholas, Blaze Campbell, Trent Carbajal, Stefan, Nutmeg, Taya, Glenn Liddell, and Dashel Hammond. And Dashel just joined, so thank you very much.
Yeah, thank you, everyone. We appreciate all of your support. And as a little token of our thanks, we're doing some bonus content around Jurassic World Fallen Kingdom. We've got now part 5 out of 6 of our Dinosaurs of the Day that appeared in Jurassic Park or Jurassic World or the books. And we also explain where you might find them in the series. So enjoy. You can check it out at patreon.com/iknowdino.
Yep, you can get prepared for Jurassic World Fallen Kingdom.
Yep.
Which you may have already seen, depending on where you live. But probably not. Jumping right into the news, we have a new article by Tsu Rui Yang and Martin Sander, published in Biology Letters, and they were trying to ask the question, or trying to answer the question of, why do dinosaurs have beaks? So previous guesses, they point out, were primarily based around flying. The idea being that having a beak allows for a much thinner and lighter jaw, as well as, obviously the mouth itself doesn't have teeth in it, and teeth weigh something, and therefore you're saving weight. So beaks are more efficient from a sort of force per weight ratio. More efficient little mechanism there. But this should have been kind of obvious that this might not have been the case, because animals don't evolve features for future use. It's not like there's an end design in mind that animals start evolving towards in a random order. They evolve every feature via selective pressure, which is the whole Darwin survival of the fittest thing. So basically, there's no reason that a bird would start evolving a beak before it could fly, or a dinosaur would evolve a beak. If it was doing it in order to fly, it needs to be evolving it for something that's useful right now. And it's possible that a feature that's evolved right now can be co-opted later, or might happen to be useful for a different path that it goes down, but there needs to be another functional purpose for a beak that makes it better than what it already has, which is, a mouthful of teeth. So it can't just be for flight. And on top of that, there are many non-avian dinosaurs that evolved beaks, like ornithomimosaurs, ceratopsians, and hadrosaurs. And hadrosaurs and ceratopsians...
They couldn't fly.
And clearly not anywhere near flying either. There wasn't any big jumping happening. They're on the ground, largely quadrupedal even. So another option is that maybe they were evolving beaks for feeding preferences as food was changing over the millennia. And this is kind of weird though, because beaks are seen in both carnivores and herbivores. And obviously nowadays you see all these flying birds and land birds, and every kind of bird has a beak with a huge variety of diets. So it doesn't seem like beaks are super restrictive or super helpful for just one specific diet. So the researchers think that they developed beaks specifically so that they could hatch faster.
Oh, peck their way out.
So that's what I thought at first. But actually what they're saying is that tooth development takes a super long time. It's something like they can only grow at 30 micrometers of thickness a day. So a large portion of a dinosaur developing in an egg is really just growing teeth. And I think it's because the jaw has to grow first, and then the teeth can start growing. And since they grow so slowly, if you have to develop these teeth, you're in an egg much longer. And what the researchers are saying is the less time you're in the egg, the better, because when you're in an egg, you're really likely to be eaten because it's just basically a meal. The same way that we eat eggs, because they're these portable snacks that are super nutritious and don't fight back. They're a great food source full of protein, all that good stuff. Dinosaurs and other animals of the time like to eat dinosaur eggs too. So if they could hatch out of those eggs in half the time or even just a few days earlier, you'd be a lot better off. So as a comparison, they talked about some similar sized eggs and how long they take to hatch. They say that a troodon took about 74 days to hatch, but a similar sized bird with a beak only takes about 49 days to hatch.
Pretty big difference.
Yeah, so that's like almost a month less in an egg, going from effectively 2 months to 3 months, if you want to look at it that way. And there are a couple issues, though, because they point out that a similar sized turtle to that troodon takes about 114 days to hatch, and they obviously don't have teeth. And other similar reptiles also take around that length of time. So it's not perfect. We're not really sure that it's just the lack of teeth that is allowing birds to hatch faster. So we need to do a few more tests. One of the tests that they propose is that we could look at more early birds without teeth and compare them to growth rates of early birds that do have teeth. It's really difficult, though, because you have to find these unhatched eggs or very young birds, and they have to fossilize, and you have to find them in the right place and time in order to be able to measure this. And it's really hard to find these bird fossils, obviously. They also said that we could test it with evo-devo research. Basically, we could do that Chickenosaurus type thing where you force a chicken embryo into growing teeth by messing with its genes and see if it takes longer to hatch. And you could do a similar thing with crocodilians by messing with the genes so that they don't grow teeth and see if they hatch faster. So that would be sort of a modern way to do it. And one of my favorite parts of the article is they point out that if Matt Barron is right about ornithischians and theropods being lumped together in Ornithocelida, then beaks would only exist in that group.
Oh, interesting.
So along with feathers only being in Ornithocelida, beaks would also be a uniquely Ornithocelida trait. Up next, we've got an article that Chris sent to us on Twitter, so thanks. And this one is also a little bit about birds. It's basically asking why some dinosaurs and not others survived the end Cretaceous extinction. And it was published in Current Biology and written by Daniel Field and others. And really, the way they started is by saying that the Chicxulub impact wiped out so much of the forests. They say it triggered widespread destruction of forests, including both an impact blast, meaning right around the impact, that leveled trees within a radius of about 1,500 kilometers or almost 1,000 miles. So that's just like this sheer pressure wave caused by the impact of the meteor or asteroid 1,000 miles away. That's how powerful this blast of air was. And then they also said that it likely caused worldwide forest fires, which we've talked about before. Basically, when the asteroid hit and shot all this material up into the upper atmosphere, it would have moved around the Earth, and then when it rained back down, it would have condensed and solidified, which releases a lot of heat, and that could have burst all the forests all over the world into flame. And then you have these widespread forest fires that launch all sorts of sulfur and ash and things like that into the upper atmosphere. And we've talked about before that causes many years of really drastic cooling, which means much less light for photosynthesis and obviously a much different climate that a lot of plants can't grow in. If you've ever had a garden, you know you need to be in the right zone in order to grow certain types of plants. So that all means that the forests were pretty much completely wiped out by the Chicxulub impact. And the reason that's important is that a lot of birds at the time lived in trees. And if all of your houses get destroyed, you're not going to survive very effectively.
Yeah. Sounds like a rough time.
Yeah, for the tree-dwelling birds at least. And they say that it took about 1,000 years for the forest to recover. Obviously, that would be many generations of these birds, so it's likely that they just went extinct because they didn't have anywhere to live. They found that there were ferns everywhere for about 1,000 years, and they describe ferns as disaster flora, which basically means that they can recolonize a totally decimated area. So in this case, the forest gets completely wiped out, and the first thing to come back is ferns. They're just really robust and good at living in all sorts of environments. And then it took a long time for the forest to redevelop on top of that. They kind of set the stage, but it still takes a long time. Once the trees are reestablished, birds can move back into the trees and other animals and then kind of start radiating again that way. But that appears to have taken at least 1 million years for the birds to kind of get back up into the trees after all the tree-dwelling birds got wiped out. And it kind of explains why some of the dinosaurs survived and others didn't. It's kind of interesting to me, though, because there were a lot of dinosaurs that weren't birds that lived on land that also got wiped out. So it doesn't really do too much to explain why some of the smaller non-avian dinosaurs died out.
Maybe their food sources died out.
Yeah, I think it might have been that, or possibly because they didn't contact incubate their eggs or something like that. But yeah, there was definitely a big collapse of the entire ecosystem. So it's likely that their food source did disappear. Maybe they were eating those tree-dwelling birds.
Yeah, could be. Or their eggs.
Yeah. It also makes a lot of sense with modern birds because we often see when certain plants get destroyed that birds can go extinct because they don't have their typical nesting area. And along with a lot of modern birds that are all over the place, like swifts, because they can nest in man-made structures and things that are similar to their natural environment. It's really seems like one of the most important things for bird survival is having their sort of natural nesting habitat.
Swallows, too?
Yeah, I think it's swallows like to live in freeway underpasses and in the eaves of houses. So both things that humans create a ton of, which is why we see so many of those birds now. But before humans, they weren't that common. They lived in like caves and cliffs and things.
It's a good thing we like them. We like them more than pigeons.
Yeah. Oh, that makes me wonder, though. I wonder if any cave or cliff-dwelling birds would have survived, because it seems like that wouldn't have gotten wiped out by the massive forest fires.
I think it also depends on their food sources.
Yeah, I guess. But these authors were specifically talking about the reliance on trees for living in.
Ah, I see.
Yeah.
Yeah, it's really interesting to look at.
It's too bad none of the dinosaurs survived. Non-avian. Or maybe it isn't, I don't know. Would have made humans a little less likely.
Yeah. It's probably for the best for us.
But now we can genetically engineer them. Let's do that.
Or make them in CGI.
I guess.
And puppets. Or we can recreate them in other ways, like Maximo at the Field Museum in Chicago, which he had his debut on June 1st. Except that they actually had to repaint him because he was just a little bit too pink compared to the real bones. He's meant to have these, quote, dusty tones of red wine and chocolate, end quote. And originally he was painted to look like the one at the American Museum of Natural History because it's the same skeleton. But that room is much darker, and in the room Maximo's in, there's a lot of light in Stanley Field Hall, so he just looked a little too pink. So yeah, people stayed an extra week or so to get the tones right. And I should be done by now, by the time this episode airs. So yeah, check them out. Next, thanks to Sarah, who shared this one with us via Facebook. There's a new dinosaur-themed band called Bonehenge, and they'll have their debut show on June 15th at CIA in North Hollywood in California. There's a fun photo in the link that we got. They're all wearing dinosaur skull hats with glowing red eyes. It looked like Triceratops, Dilophosaurus, Parasaurolophus, some kind of sauropod, probably Brachiosaurus. It looked pretty cool, so I wonder where they got them. Although, we did just see a big Jurassic World Fallen Kingdom promotion in Taipei, and it looks like they had a showcase of merchandise. And some of the stuff looked similar to what this band is wearing on their heads, so I don't know. Maybe it's Jurassic World related.
Could be. I think looking at the Mattel stuff that they've made, there's just the raptor hat. I don't think they have the other ones.
Okay. Well, either way, these are pretty cool.
And that display we saw was really awesome. They had a full-size T-Rex sculpture and also a Jurassic Park style velociraptor.
I think it was meant to be blue.
Yeah, I think so. And apparently some kind of VR thing that was open in the daytime, but we got there pretty late.
Yeah. And they made sound effects.
Yeah, they had pretty loud sound effects going.
And it was set up the way Jurassic World was set up with their merchandise area. Do you know what I'm talking about, Garrett? And then that last scene in Jurassic World where it's the T-Rex fighting Blue and the Indominus Rex.
Oh, you mean on the main street?
Yeah.
Yeah,
and Claire and Owen and the kids, they're hiding behind some shops or some merchandise and stuff. So it's set up kind of like that.
Yes. Claire and Owen were not there.
They were painted there.
Oh, they were? I didn't notice that.
Yeah, in one of the boxes or whatever you call it, warehouse
Little
type things.
Fake storefront style things.
They're in a gyrosphere.
Oh, cool.
Yeah.
Yeah, we'll share pictures. Well, actually, we already have shared pictures as of this airing on Instagram, if you want to check that out.
So the rest of our news is actually all related to Jurassic World and Jurassic Park. Maybe not Jurassic Park this time. Could just be Jurassic World. Starting with, in Grand County, Colorado, John Hankel and his wife, they have this business called The Collective Collection, and they rent out fossils to museums and movie studios. And he said he got into it because he was hooked on dinosaurs since he was a kid. So he helps dig up fossils, and then he makes rubber molds and replicas. And they moved to Grand County with 40 dinosaur casts. And those are the ones used in museums and movies. And last year, his family actually donated their whole private collection of about 600 bones to the Museum of Nature and Science in Denver, which we talked about, but I didn't realize that was his whole private collection. So
that's cool.
Yeah, that's really awesome. And some of his casts, bringing it back to Jurassic World, they'll be in Jurassic World Fallen Kingdom, and some of his skeletons are also going to be displayed at the movie premieres, or may have already been displayed at movie premieres.
Cool.
Yeah. In games, Frontier Development released another development diary of Jurassic World Evolution, and in the game, they talk about how you go on expeditions to get fossils and extract DNA, and then you use that to build your dinosaurs, and each dinosaur has different motivations. Some want to hunt, but some just don't want to be lonely. Give them some friends. You also have to worry about diseases, so there's some great graphics, because of course, it looks like Jurassic World, so.
Sounds like they're making it a lot like an actual zoo. I'm so excited for that game.
There's another cool video that came out, and thank you to Stuart who shared this one with us via Facebook. It's really well done, really pretty to watch. It's about 5 minutes. It was sponsored by Jurassic World Fallen Kingdom, and it features Devin Supertramp, which I think is a YouTube channel they've got going, doing parkour and acting out scenes from the movie. It was published on June 1st to let you know that you can buy Jurassic World Fallen Kingdom tickets now. And again, their YouTube channel is Devin Supertramp. It looks like they do this for a lot of movies and shows. So in this one, they actually got to film it on the site of the movie, or at least parts of the sites. And pretty much everyone in the video does parkour, including there's people that are in the inflatable T-Rex and Velociraptor costumes, and they're doing parkour as well. It's really impressive. So most of the video is this T-Rex chasing a guy who's dressed like Owen Grady. And there's also somebody dressed kind of like Claire, but she's not in the video too much. At one point, the guy who's dressed like Owen Grady is surrounded by 2 T-Rexes, and someone in the blue Velociraptor suit jumps out from the bush to save him. And then one T-Rex keeps chasing after him, after the Owen Grady guy, and they run down the hill the way the dinosaurs in the trailer are running away from the volcano. The T-Rex also ends up kind of searching for the guy in this abandoned warehouse bunker type thing. And then the guy ends up rolling down the hill in an inflatable bubble, which looks like it's supposed to be like the gyrosphere.
So he's rolling in one of those big ball things.
Yeah, and then the T-Rex is following him, and then they roll off a cliff into water.
Oh, no.
Some pretty good stunts. And they end up on a beach, and then running into a city with a bunch of people, and the T-Rex just keeps chasing this guy, and eventually the guy meets up with the woman dressed like Claire Deering. She's shown in the beginning of the video, and they show her again at the end, and they're in front of the theater, and it says, Jurassic World Fallen Kingdom, June 22nd.
So they basically ran from the volcano all the way to a theater.
They did. And then the T-Rex catches up. Well, they're trying to get in the theater, and the ticket person at the theater says you have to have a ticket, and they don't have it with them, and then the T-Rex catches up and the ticket guy runs away, and then the T-Rex, the guy in the suit, takes off his suit and he starts yelling at him like, why were you running away? I was lost. That's why I was following you to get out.
That's funny.
Yeah, and then he keeps yelling at him, why did you jump off that cliff? So, really well done. Even though I have explained the entire video, I still recommend watching it if for anything the parkour tricks. It looks like they also made a video last year for the first Jurassic World. I haven't watched that one yet. And then, of course, they've got the YouTube channel for all kinds of different shows and movies. So we will share a link and you can watch it for yourself. And we've got one last bit of Jurassic World Fallen Kingdom news. And just to note, this one has a lot of spoilers. Director J.A. Bayona, he's the one directing Jurassic World Fallen Kingdom. He talked about his work to Irish Times. Apparently, he was asked to direct the first Jurassic World, which maybe we talked about, but I couldn't remember. The timing at the time wasn't right, so they ended up with Colin Trevorrow. And Bayona said, quote, you put yourself in service of the saga or the franchise when you take on one of these movies. You want to make the best Jurassic movie possible. You're not coming in to hijack Steven Spielberg's baby or Colin's baby. For me, as a director, it was very exciting to be in charge of the second episode. For me, the story is established and I'm the person who gets to turn the Jurassic World upside down. It's very interesting to do a chapter that's very different to anything that's been done before, end quote. So to prepare, he rewatched all the films, he reread all the books, and then took notes on his favorite scenes, and he really liked those moments of suspense. Like in the first Jurassic Park, you've got the scene of the velociraptors in the kitchen. There's also the one with the T-Rex going after the car. And he said he was a fan since the first movie came out, and he saw these CGI dinosaurs on the screen. He said, quote, I felt that I was witnessing something that was pivotal, something that would stand the test of time, but I was also excited because I knew from that moment on that everything was possible on the big screen. And that's why Jurassic World Fallen Kingdom is going to have so many more dinosaurs, and also this new Indoraptor character, because apparently they designed this Indoraptor in consultation with this guy, Jonathan Cranston, who's an English veterinary surgeon with experience with wildlife in South Africa. And we also talked a little bit about this before. They talked to a lot of kids who like dinosaurs to also help them form this Indoraptor. And Bayona said, quote, we had a lot of expertise on the film, but the opinions of kids I almost value even more because they're so honest. I was very interested in the way that they talked about dinosaurs. They talk about textures and colors. I wanted to create a dinosaur that would be very memorable and very scary for them. I wanted to create something that was very dark, almost black, with very white teeth, so that when you see it in the dark, it's very effective, just a set of eyes and teeth. End quote. Yeah. So that gives you an idea, and this is going to be a suspenseful movie.
Yeah, that's awesome. It's going to be creeping out of the shadows, possibly.
Yes. So, just like Jurassic Park, all these characters are grounded in some kind of reality, but then they do the artistic license, and then the second half of the movie is more like a haunted house story, and it's about the tension, not the special effects.
Nice.
Yeah.
Yeah, the first Jurassic Park did a lot of tension and like thriller, sort of waiting for what's going to happen. But the other movies haven't really done that at all. It's much more action-adventure style. So that'll be cool to go back to that. Except, I guess, in the second movie, when they're kind of like teetering off the cliff, and one of them is laying on the glass as it's like starting to break.
Oh, yeah.
That's one of those kind of intense waiting to see what happens moments.
They always have at least one moment like that,
Yeah.
I think.
Yeah, I suppose there were like one or two in Jurassic Park 3 and Jurassic World also. But the first movie had just a ton of them. It was great.
Yeah, and his last quote about the movie that I really enjoyed anyway was, quote, as a story, the movie is not about dinosaurs, it's about human beings. It's not about how technology is affecting dinosaurs, it's about how technology is affecting us.
Yeah, I think that's kind of how Michael Crichton originally thought of it, so it makes sense. And before we get into our interview with John Hutchinson, who helped make T-Rex Autopsy, that awesome show, come to life, we have a word from our sponsor, TRX Dinosaurs, who also makes all sorts of amazing dinosaurs come to life. So if you're interested in getting a awesome puppet or posable sculpture or animatronic of a dinosaur, then head over to trxdinosaurs.com and let them know what you're interested in. I wonder if they've gotten any requests for the dinosaurs in Jurassic World Fallen Kingdom yet.
I've seen pictures of baby T-Rexes, if that counts.
Yeah, that'd be Jurassic Park 3. But unless there is a baby T-Rex in Jurassic World Fallen Kingdom, there could be. We don't know yet.
Or the fact that Jurassic World Fallen Kingdom is coming out makes people think, oh, I want a baby T-Rex.
Yeah, that's true. But yeah, maybe some of the new unique ones. I guess we don't really know many of the dinosaurs from Fallen Kingdom yet. But if you see that movie and you see something that you want, then you should let them know. Or perhaps you see the T-Rex Autopsy and you think, I want a T-Rex that I can pretend to autopsy. They might be able to make that. I don't know.
Minus the smells.
Yeah, you don't want the smells. But yeah, so head over. They have a form where you can fill in what you want. And they really like creating new and interesting things. So whatever you can think of, put in there and see what you guys can make together. And if you're interested in getting a free Velociraptor sculpture, non-Jurassic Park style Velociraptor, real Velociraptor style, then check out the giveaway link in this week's show notes. The link is bit.ly/Velociraptor185. And Velociraptors with a capital V, just like it should be. As a reminder, the giveaway is open to residents of the US and Canada, except Quebec and where prohibited. There's no purchase necessary. You can make an entry every episode, once per household, and complete rules are on our website.
And now for our interview with John. Today we get to chat with Professor John Hutchinson, who's a professor of evolutionary biomechanics at the Royal Veterinary College in the UK. He's also an associate editor for Proceedings of the Royal Society B and Peer J, and a fellow of the Linnean Society of London, the Zoological Society of London, the Anatomical Society, the Higher Education Academy, and the Royal Society of Biology. And his research focuses on locomotion and anatomy, and he studied many types of animals, including dinosaurs, elephants, crocodiles, and early tetrapods. And he's also known as a world-renowned T-Rex expert.
Yes, I am, I guess.
I'd say you are. Actually, yeah, just diving right into that, can you tell us a little bit about your work with the T-Rex autopsy?
Oh, with T-Rex Autopsy. Okay, that's a fun start. Well, yeah, so let me think back. That was, 2014-ish, 2015? Anyway, yeah, around then, got contacted to be a consultant for this show in which they were building a life-size dissectable T-Rex, and the guy who was building it was one of the guys who built Jabba the Hutt for Return of the Jedi, the film, among many other things. He was involved in the Dark Crystal movie and so forth. So he's a legit model maker for movies. And anyway, that was the feature part of the T-Rex Autopsy, was dissecting that. And there was some CGI as well, of course. And my role as a scientific consultant was brought in early to critique the anatomy in general of the T-Rex, especially my expertise, which is on the parts behind the head. The head is just a big triangular thing to me with big teeth. I know that much. But anyway, to critique the anatomy and then also to talk about on screen as kind of a guest appearance, to talk about my research on locomotion of T-Rex. So that's what I did. And also during the filming, I got to be there behind the scenes while they were doing the dissecting with a crew of about 20-ish international journalists. We were hanging out behind a glass panel, watching from on high, watching the dissection proceed. And I was explaining to them as kind of their guide to what was happening so they could write about the actual filming as it happened. That was really cool. I've never done that with a documentary before. Actually been there with journalists during the filming, which is quite unusual for that to happen. Usually journalists don't get to know anything until the documentary is finished, but they wanted people there to document the one-off occurrence of dissecting a T-Rex, which will never happen again, probably. And not in the same way, anyway.
Does that mean you were far enough away that you didn't smell anything? It sounded like, or when we watched it, it looked like there were some smells.
Yeah, they had some surprise smells hidden inside the carcass because there was some decomposition at play there. So we were insulated from all that. I'm kind of disappointed. I would have liked to know what they thought a T-Rex would smell like. But according to the people that were there doing the dissection, it was pretty nasty. And they were surprised. They didn't know this was going to happen, that it was going to be that bad.
I guess that makes for better TV.
If I remember right, they didn't even know there was going to be smell. I think they were just expecting it to smell like rubber.
That's funny.
That's how it looked, actually. I remember thinking that.
Yeah. That was a really cool show. It was pretty unique. I'm impressed that they went that way with having journalists there and things too, because I've never heard of that either in a documentary. That's pretty unique.
Yeah, it was really a one-of-a-kind show, and I've done over 20 different documentary episodes in my short career, and that one really stands out as one of the most ambitious and really unique. They put so much effort and thought into it. They really wanted it to be done right. They wanted lots of science to be in it. They really cared about that. It wasn't just a gee whiz science fiction thing. In fact, they dispensed with the backstory, which I thought was really smart. They were just like, okay, we have a T-Rex, go. There's no explanation of how they got the T-Rex. How the heck would you ever have a cadaver of a T-Rex? And no consequences at the end. They were just like, okay, we're done, and the show ends. So I really like that. It's interesting kind of coincidence that I was filmed for another show a couple years beforehand that was rather science fiction, in which a bunch of scientists were brought to the north slope of Alaska to study a T-Rex before it fell off a cliff. The T-Rex was coming out of ice. It was frozen in the ice and was about to fall into a chasm and forever be lost to science. But the scientists had a short while to study that T-Rex. And so we got filmed in an interview, like to talk about the situation or something like that. I don't remember, but the show never happened. So we just got the filming done. There were quite a few international experts filmed for this, but then nothing. We never heard any more. But I'm kind of glad, because I always felt like it is a really stupid idea for a program, because we'll never find a T-Rex in ice. There's no Cretaceous ice left over. There's no way you could find a T-Rex in ice. I think T-Rex Autopsy was better off just not even trying to set a context, just total fantasy, and using the fantasy as vehicle for, well, okay, let's learn something about T-Rex anatomy and so forth.
Yeah, I thought they did an excellent job. I was really impressed too with how many scientists they got involved, even doing the dissection, that they got, these real renowned scientists to do the on-screen work, so that no one was paraphrasing their words or, accidentally misstating anything. It was great.
Yeah, it was a cool team. They had the vet and an elephant paleobiologist who had dissected mammoths before, real ones, I think, one or two, and then a couple of tyrannosaur experts. So yeah, perfect.
Was the vet the guy that ended up like climbing inside it?
Oh yeah. He was the kind of what's that celebrity chef? The blonde guy who swears a lot.
Is it Gordon Ramsay?
Yeah, Gordon Ramsay, like super testosterone-ridden guy who's like, yeah, let's go, let's get a chainsaw and cut this T-Rex open. Oh, it's just, yeah, definitely added some humor content and so forth. It was a good choice. And I think if you dissected a T-Rex, you probably would want a vet involved, because they would know something about some of the problems you might encounter with a dissection, and pathology and risk of infection and other health issues that a regular biologist or paleontologist might not know.
Mm-hmm.
Yeah.
Yeah, if you're just dealing with bones, you don't worry about any of that.
No.
So I saw you've also worked with David Attenborough, and a couple times. Yeah, the most recent one is Jumbo, The Life of an Elephant Superstar?
Mm-hmm. That was fantastic.
What's it like to work with him?
It's just what you think it would be like. It's just like he is on screen, just really nice, He's full of stories. That really struck me. We got to go out to dinner quite a bit as a group, the whole crew and people involved on camera. And he just was really fun, loved to talk about stuff, things he'd experienced, loved good food and wine and stuff like that. It was just a bon vivant in general. And amazing energy for a 95-year-old. Or anyone, tons of energy. Like, we arrived on the plane from London to New York, and I was like, okay, I'm going to bed. I'm exhausted. And he was like, okay, I'm going out partying. Let's go dancing. I was like, what? Yeah, he got to go first class. I didn't, but still, you get off a plane, you should be, yeah. I just didn't get it. I don't know how he does it.
Yeah.
But he still, I asked him, like, how do you like go to Borneo and all these places, long travels? And he just said, how do you handle being on the plane and all that, all these really long journeys? It must be really hard. I mean, I have a hard time coping. He said, no, I don't. It's horrible.
He parties through it.
Basically. He has to grin and bear it, which is kind of my attitude too. I don't love the traveling, but I just kind of get in the zone and just go and hope that it ends soon enough and the fun part begins.
Yeah.
Yeah. Well, I mean, speaking of which, you just came back from a trip to Seattle and the Burke Museum, and you gave a talk about dinosaur movement. So how was that? What kind of things did you share?
Yeah, I talked kind of about my overall arc of my career, from starting off studying T-Rex anatomy and movement as a PhD student and postdoc to what I'm doing now, looking at how early dinosaurs got started and their movement, what made them similar to or different from other animals that they lived alongside, the crocodile lineage of archosaurs that were all around in the Triassic period. So I've kind of come full circle from focusing on things at the end of the age of dinosaurs, the late Cretaceous with T-Rex, to now looking at the beginning of the age of dinosaurs and how these little, like, house cat sized dinosauromorphs and early dinosaurs, how they got started, and really, really different animals compared to a T-Rex, and more about beginnings than endings.
Cool. Since you bring up the early dinosaurs, that just made me think of the whole Ornithoscelida debate. Do you have an opinion on that?
It's very interesting, yeah. People have bandied kind of similar ideas around for a while, and that's where Ornithoscelida comes from, and it's an old term that was hypothesized. I think we're at the point now in studying the family tree of dinosaurs where we're starting to know so much that things are getting blurrier. That seems to often happen with phylogeny, with the study of evolution, that as you get more data, you kind of get toward that part of the tree where branches easily move around or get blurred. I don't quite know how to describe it, but I think we're that way with the origin of birds. Like, is Archaeopteryx a bird or not a bird? What is the closest relative of birds? Is it the Troodon lineage, the Dromaeosaur, Velociraptor lineage, or both of them? That used to be kind of consensus that Archaeopteryx was a bird and not further away from birds than Dromaeosaurs and Troodons. But now things are kind of up in the air, and I think it's the same thing with that sector of early dinosaur phylogeny, that we've got so many specimens that it's easy for slight changes in what species you include in your analysis and what characters you use and so forth to give you rather different conclusions. And I think that's a healthy thing, that we shouldn't settle into dogma. We should be questioning the fundamental concepts of family tree of dinosaurs and so forth. I don't have a horse in that race. I don't particularly care, but I watch it because it's important. Everything we do in comparative dinosaur biology depends on having some sort of tree of dinosaurs to test our hypotheses against. So it is important. All those questions about who's related to whom in dinosaur and archosaur evolution are very, very important. And interesting times. We'll see. I don't know. It's a wait and see kind of situation for me, but it may not matter for some questions which hypothesis you use. Some of the stuff I'm doing, I don't think it really matters tremendously. And a lot of early dinosaurs, whether they're ornithischians or sauropodomorphs or theropods, are all pretty similar. And that's probably part of the problem, that we're getting animals that are just so similar and only like a character or two separate them. And that to me also is why it may not matter in the end that, well, if they're all so similar, some of the questions we ask may not really matter who's related to whom. They may have all acted in similar ways. Once you get to that very fine-grained level of detail, there may not be that much different between them in reality.
Yeah, I guess that's a good point, because if they were really different, it'd be easy to kind of parse out the family tree. The issue is that there are all these blurred lines and they have so much in common. So then if you're looking at things like biomechanics, it's like, well, yeah, they have a lot in common. They probably moved similarly, and then you don't really need to worry about it too much.
Yeah, with biomechanics, there's such big error bars, so to speak, on our estimates of what animals can do that if animals are pretty similar, you really have no hope of telling them apart, especially with extinct animals from skeletal remains. So the most testable questions are with animals that are pretty different.
Can you tell us a little bit about your work specifically on how dinosaurs moved?
Sure, yeah. So the project I'm doing now that I'm really excited about is called the Dawn Dinos Project, or Dawn of the Dinosaurs. It's funded by the EU. They gave me an advanced investigator grant, which is one of these multi-million euro grants to work for 5 years on a big problem that interests me. And this was the one that interests me. Is there's the idea that dinosaurs survived the Triassic because they had what's called locomotor superiority, that something about them was better than in the crocodile lineage, the big clunky armored crocodile-like, or land crocodiles as I like to call them.
So the Pseudotsuchians?
That whole lineage. Yeah, the Pseudotsuchians or Suchians or whatever you want to call them, the lineage that led to true crocodiles, but got wiped out almost entirely at the end of the Triassic. So why did that crocodile lineage get almost wiped out and dinosaurs flourished at the end of the Triassic? Well, is it locomotor superiority? Is it blind luck in the case of dinosaurs? That's what some people have argued. But no one's really tested it. So people have looked at like limb proportions of early dinosaurs and said, oh, early dinosaurs had long legs. So maybe that meant they were fast. Maybe that supports the locomotor superiority hypothesis. But locomotion isn't just about limb proportions or anything else like that. In fact, limb proportions can be very misleading, as I showed, I think, with my T-Rex work. Yeah, it has long legs, but that doesn't mean it's fast, just like a giraffe is not fast. We need biomechanics to test these kind of hypotheses that are biomechanical hypotheses. If you want to understand how fast an animal was, yeah, you can try doing a plot of speed against limb length, but that's going to be incredibly inaccurate because you're throwing together data from hippos and giraffes and kangaroos and whatnot to try to estimate the speed of a dinosaur from limb length, when none of that is really that relevant. Whereas if you build a dinosaur from first principles, like in a computer model, and really represent the dinosaur as the dinosaur with all its real anatomy and musculature and so forth, and try to test how it worked using biomechanics, including physiology and physics and everything, then I think you can get more reliable answers because you're really directly in the sense of a computer model testing how something worked, rather than very, very indirectly using some sort of statistical analogies. The point is that we're trying to use this computer modeling approach that I've used all along to address how early dinosaurs moved, kind of, taking tools that I developed to study T-Rex and bringing them back to the Triassic. And I'm really excited about that because I get to work with some of those really weird Triassic things that we know very little about. Like, we don't even know some fundamental things about some of them, like which ones were bipedal. Some people kind of assume that dinosaurs started off bipedal and then got quadrupedal, but I'm still not totally sure. I think it's pretty likely, but some of those animals we don't know that well, and testing bipedalism is pretty tricky. And on the crocodile line, there are some animals that look like they were bipedal, but do we really know if they were? Some things like Poposaurus, a weird thing that looked like a crocodile that probably did walk on two legs. I think that's not very controversial. It had such short forelimbs that it's hard to imagine how it could have ever moved on all fours. But there are other things on that lineage, like even early crocodiles, that some people have proposed maybe they moved on two legs. It's all very interesting for me to study these weird and I think neglected animals. I've studied T-Rex for a long time, for about 20 years. I've published somewhere around 12 papers on anatomy and movement of T-Rex. I feel like, okay, enough about that. I really need to study something else. I love T-Rex. It's a great dinosaur. I've studied it for, I think, very valid reasons, but I do get bored of it sometimes. I hate to say. I shouldn't say that on a forum like this, but I do feel that way quite often, even though it does pay the bills and gets me on documentaries that are important for science communication and so forth. And so I don't shirk that duty or scorn it, but still sometimes in the dead of night, I lie awake at night thinking, oh, what have I done with my life?
It makes sense. There's so many aspects of dinosaurs to study. So it makes sense that you'd want to learn other parts.
Yeah.
Yeah. I mean, you study one thing for too long in science, you will get kind of bored with it, even if you love it. There's always kind of the yin and the yang there in science, that the more you learn, sometimes the familiarity breeds contempt, I guess. So yeah, it's good to have a breath of fresh air and shake things up. And that's what these grants are like. The one that I got to study the dawn of dinosaurs is really to do a change of pace and study something rather new. Although it's not totally new for me. One of the first papers I ever published was really started with the early dinosaurs and said, well, here's what we would predict from anatomy happened in the first dinosaurs. Like, here are some muscles that would have changed the way they worked, and here's how we get from a crocodile-like ancestor to a bird-like descendant or a modern bird. We kind of went along the family tree from early archosaurs to modern birds and predicted from anatomy how function and locomotion should have changed. And in this paper, in a way, is kind of revisiting that early paper from 2000 with Steve Gatesy, that it kind of proposed some hypotheses, I guess, or made some inferences and speculations that were qualitative. There was not any real biomechanics there, but there was pretty good functional morphology and anatomy and so forth, and phylogeny brought to bear on what data existed at the time. So now, 18 years later, we're gonna throw some computer power at this, and we're doing some studies that we're almost done with Nile crocodiles and little birds called tinamous, to see how those living animals work. So add some real data on real living archosaurs, the living descendants of those Triassic ancestors, and see how they work, and then kind of go back through time into the Triassic armed with those data to better understand how extinct archosaurs would have worked.
Cool. So it's still pretty early days for this?
Oh, yeah. We're just less than a year and a half into the 5-year project. So there's 3.5 years to go. We're now heading into the heavy computer modeling phase in the next few weeks, and that will dominate the remainder of the project, having finished working with the Nile crocodiles and the tinamous, which was fun, but really different from plugging away at a computer.
Yeah.
I can imagine.
So at the Royal Veterinary College, you teach inheritance, genetics, and evolution, and comparative animal locomotion.
Yeah. My job really is largely research these days. I used to be more heavily involved in teaching. It's just kind of the way things evolved during my career. But I teach a few lectures on evolution and a few on biomechanics, and a scattering of other lectures to our undergrads in different programs.
Cool. I guess I don't usually think of dinosaur experts at a veterinary school, so how did you end up there?
Yeah, that's always a good question. Well, I needed a job back in 2003. I was about to be unemployed as a postdoc, and that's always a very, very scary transition. Very stressful, but luckily I had some colleagues at the Royal Vet College who were setting up the Structure and Motion Lab, and I really got along well with them. So they said, hey, come for an interview. You'll trip to London. And I thought, do I really want to move to London? No. And then I wrote back and I said, oh, actually, yeah, what the heck? I'll do it. So I applied and interviewed and got the job. And once I saw the place, it really hit me. Like, I was like, oh my God, this is an amazing lab for studying animal movement, which was something I did. So I've always been about studying the movement of animals, whether they're living or extinct. To me, it doesn't matter. It's just the approaches you use may differ, but the questions are and to me, the fundamental questions are about what limits the way animals move, like body size or anatomy or something else, and how movement has evolved. And so to answer those and put them together to see what kind of broad patterns you get in different groups of animals. So I've studied elephants and crocodiles and so forth for their own sake, because they're cool on their own right, but also then I've studied extinct things like T-Rex and so forth for their own sake, because they're interesting, but also to understand their evolution. So going to a place where everyone else except for me studied living animals just made sense, because that's what I do too. And I like the idea of being the black sheep who studied extinct animals. It's a good niche to have. It's good as a new faculty member to be doing something different, as well as have enough overlap that there's synergy there where you have common ground and can talk about stuff and collaborate. And I saw plenty of that kind of opportunity. And 14 years later, that decision was definitely a good one for my career. I've loved it at the Royal Vet College. It's grown from less than 10 people when I started to now over 50, and little plastic tunnel where we had to work exposed to the elements to gather our data, to now 2 giant kind of aircraft hangar sized buildings with more research toys than we could ever want. We have a hard time writing grants, to be honest. I'm not complaining, but when we write a grant to get stuff, we don't need to buy equipment because we have everything and we've got amazing facilities. Our grants end up being pretty cheap by and large, because all we need to pay for is usually people and travel and other stuff, rather than buying expensive pieces of equipment often. So having a well-stocked lab with lots of people around, lots of intellectual synergy to build upon, not only makes your grants affordable, but also gives reviewers something to praise for a strong research environment. Whereas if I was just one lone faculty member in isolation with no one else and only a small amount of equipment, I'd have a harder time getting funding. So it certainly helped me, and I've reciprocally helped the rest of our group with their careers, because we all benefit from this environment.
So we've kind of covered, you've done amazing work in so many different ways, but in addition to all of that, you also have a blog. It's What's in John's Freezer. What kind of posts go up there?
Yeah, so that got started about almost exactly 4 years ago. It just had its anniversary on Saturday.
Congrats.
Yeah, got started kind of on a dare. Actually, it's more than 4 years ago. Or kind of as a joke. Science writer Ed Yong was visiting our campus, and I showed him my freezers as I normally do. And I think, if I remember right, I joked to him, "Oh yeah, I could do a blog, What's in John's Freezer?" because there's so many neat things in there. And then it hit me as I said that. I was like, yeah, I really enjoy doing that. And so I did it. So I just started writing about specimens that are in my freezers. I get donated cadavers from animals that die in zoos, and I use them for my research, anything from elephants, crocodiles, ostriches, whatever, even some weird things. I have bits of buffalo and giraffe and all kinds of odd things in my main big freezer, as well as some chest freezers. And so I talk about, well, what do we study? What do we use these things for? What do we learn from them? Sometimes it's gruesome. Sometimes it's funny. Sometimes it's both. Sometimes it's just interesting. But it just use it as a platform to talk about whatever I find interesting, with the hope that other people will find it interesting too. And I think that's worked out pretty well. Occasionally I weave in some other story, like just from my own life, problems I've had with my own anatomy, so illnesses I've had, injuries I've had, and even showing like CT scans of a broken shoulder and talking about how that happened. And it's just been a fun place to talk about science and anatomy and things related to that.
I really like that you have the stomach churning rating, 0 to 10, were you getting comments like, "Oh no, I wasn't ready for this gruesome thing"?
Yeah, I thought very early on when I was writing the blog, I thought, oh yeah, this could rub some people the wrong way. So I wanted to have always at the beginning of a post a little warning there, like what is going to be in this post before the blood and guts come, if there is any.
Have you rated anything a 10?
There certainly were some 8s and 9s in there with intestines and rotting things tend to rate pretty highly for me. I tend to rate what makes my stomach churn. And yeah, the digestive system for me is up there.
Yeah. We were at the Western Science Center in California recently, and they happened to be dissecting an owl while we were there, and I think he had just gotten to the point where like the intestines were kind of hanging out of it, and he was like, "You don't want to be around when
he opens it
this,
up." Yeah,
this part.
Yeah, just like that T-Rex autopsy.
Yeah, the smells.
Puncturing the digestive tract unleashes some nasty stuff.
So, in addition to your blog, are there other places where people can find out more about you and your work?
Well, our Dawn Dinos project has a website, dawndinos.com. I'm on Twitter regularly, where I talk about whatever comes to mind. Yeah, those are the main places right now that are active. I've dabbled with a couple other social media things, but right now those are dormant. So I'd recommend the dawndinos.com or the What's in John's Freezer blog, or just the RVC website, rvc.ac.uk. If you look around there for Structure and Motion Lab, that's where we are.
Great.
Awesome. What's your Twitter handle?
At John R. Hutchinson.
Well, thanks so much for chatting with us today. That was really great to hear all your stories.
Yeah, thank you.
Thank you. That was great fun.
Thanks again, John. We had a great time chatting with you.
Yeah, I wish I could have seen that T-Rex autopsy up close. It looked so cool on TV.
Yeah, it did.
And the smells. Why? Why the smells? The things they do for a reaction on TV.
It's a pretty good one.
Yeah.
And now on to our dinosaur of the day, Pro Compsognathus, which appears in both Jurassic Park books, not actually in the films. Compsognathus are the ones that appear in the films.
Yeah, for some strange reason. Maybe just because it's more fun to say without the pro.
Yeah, it might have been too long of a name otherwise. So in the books, they are a little bit venomous, and they like to attack in groups. They end up killing John Hammond at the end of the first book.
I'd say spoiler alert, but that came out like 25 years ago.
More.
So you should have read it by now.
Yeah, more than 25 years even. And then they have a smaller role in the second book. But this is to go along with all of the dinosaurs that we are covering that appear in Jurassic Park and Jurassic World. And again, if you're a patron, you can hear our bonus content on this. So unlike the book, there's no evidence that in real life Pro Compsognathus was venomous. But it was a coelophysid that lived in the Triassic in what is now Germany in the Lowenstein Formation, and its name means before elegant jaw, and that comes from the name Compsognathus, pro, before, and elegant jaw, Compsognathus, and that's because Compsognathus lived later in the Jurassic. Pro Compsognathus looks similar to Compsognathus, but there's no evidence that it was a direct ancestor. It was found in 1909 by Albert Bührer. The holotypes of an adult and included a crushed jaw, vertebrae, ribs, a forelimb, and hind limbs. Bührer sent the fossils to Professor Eberhard Frost to the State Museum of Natural History in Stuttgart, and in 1911, Frost referred to it as Holopus celerimus and thought that it was a jumping dinosaur that helped show the origin of birds. And then in 1913, Frost officially named it Pro Compsognathus. The type species is Pro Compsognathus triassicus. In 1921, Frederick von Huene referred 2 more specimens found in the same quarry, back in 1908, to Pro Compsognathus, which included a partial skull and lower jaws and a left hand. However, there's controversy about von Huene's referred specimens. John Ostrom in 1982 said that they were from a different taxon, and Fabian Knoll in 2006 and 2008 found that they were a crocodilomorph or some basal archosaur.
Oh, way off then.
Yeah. Then in 2012, Knoll confirmed with a CAT scan that one of the specimens was a crocodilomorph. So there's a lot of debate over where to place Pro Compsognathus in the dinosaur family tree. It may be most closely related to Segisaurus, Hallei, just talked about that one, Pro Compsognathus lived in a dry inland environment. It was small and light and bipedal. It grew up to 3.3 feet or 1 meters long, though estimates vary. Gregory Paul thought that it could weigh 2.2 pounds or 1 kilogram, and that it was 3.6 feet or 1.1 meter long. Pro Compsognathus had long legs, short arms, and claws. It was probably a fast runner, and it had a stiff tail. It had a slender snout with lots of small teeth, and it probably ate insects, lizards, and small prey. Other dinosaurs that lived in the same time and place included Coelophysoids, Haltocosaurus, and Dolichosuchus, sauropodomorphs, Plateosaurus, and Euphrasia, as well as an unnamed Herrerasaur and some theropods, although only tracks have been found. And the type specimen of Pro Compsognathus is at the State Museum of Natural History in Stuttgart in Germany.
And our fun fact of the day comes from a really great paper titled Ancient DNA, A History of the Science Before Jurassic Park by Elizabeth Jones. And really what she did was she looked at where this ancient DNA idea came from. And the most interesting one to me was from a paper called Dinosaur Capsule in 1985, which is obviously about 5 years before Jurassic Park was published. And in it, Charles Pellegrino talked about bringing dinosaurs back to life. So the way he said that he got his inspiration was going to New Jersey and finding a 95-million-year-old fly trapped in amber, if that sounds familiar, saying that in their, quote, stomachs may be some undigested bits of their last meals that came from animals, including dinosaurs that roamed the earth millions of years ago, end quote. And also that lost paragraphs of codes in their DNA could be filled with contemporary animals. So another thing that's very similar to Jurassic Park.
I was just thinking that,
DNA. Yeah. That's why I found this piece the most interesting. He also speculated in 1985 that, quote, 3 more decades of technological advance, and we may be able to extract and read DNA from the fly's stomachs, where, if we are lucky, we will find the blood and skin of dinosaurs, end quote. And unfortunately, 3 decades ended in 2015, and we're not even remotely close to doing this. So,
well, we got a new Jurassic movie in 2015.
That's true, we did. So I guess he got
close enough.
Yeah. So just to clarify that I don't think Crichton really completely stole this, or possibly didn't steal any of this at all, because he started researching making a dinosaur book back in 1980, and there are records of him talking with researchers about insects trapped in amber, most likely in relation to dinosaurs back in 1983. So there were really just a lot of people thinking about this at the time, because DNA had recently been discovered, and we were kind of entering back into the dinosaur renaissance. So it's kind of worlds colliding, and a lot of sci-fi authors were thinking about this kind of thing. So yeah, there were a lot of other authors that they mentioned in this paper from the late 1970s and mid-1980s who were discussing ancient DNA. But it's just interesting to me that it did start quite a bit before Jurassic Park. It's just Jurassic Park is the thing that really launched it into the public consciousness.
Yeah, and that so many other people were considering this idea.
Yeah, and that this guy, Charles Pellegrino, basically did the exact same kind of idea as Jurassic Park in an essay, which I couldn't find anywhere. I tried pretty hard to find this essay, and I have no idea where it ended up.
Just out in the ether.
Yeah, it's somewhere. All that stuff pre-internet can be really hard to find sometimes.
And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. Check out our Patreon page for exclusive content, especially around Jurassic World Fallen Kingdom, but also content about our recent trips to museums around Asia.
Oh yeah, lots of those.
Yeah, and don't forget to check the show notes for a link to this week's giveaway. Thanks again, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.